through a lot of the syntax, whys of the syntax. By the time it's done, you'll have at least seen once how all of it all the language is laid out and what works and how it works. And that should at least, I mean, even if you don't remember it verbatim, it will give you the opportunity to remember, oh yeah, I can go look. And to let you know, right here is all this stuff is on GitHub at that link right at the top. And once you get there, you can get any of my 3 talks. There is a version of the talk with, here it is. There's a version of the talk as a Jupyter Notebook. There are versions of the talk printed as PDFs, so you can just read it. And on top of that, there is an active, why don't I show that here? Okay, go back here. In the README, I talk about how to actually go and run it, even if you don't have Python installed. So the Jupyter Notebooks are hosted on a service that allows you to go there, click on it, and use a live Jupyter Notebook and play around. So like, well, sort of like PyFiddle, which is another thing you can do. Okay, but let's get going. Just make sure you have that down, and you should be fine. And by the way, my name's Chuck. So Python is free, open source, object-oriented programming language. It's distinctly different from other object-oriented programming languages. So if you hang around for my next talk, you'll see how and why that is. This community is super strong. It's a growing language. Its community has been growing the last couple of years, while some languages have been shrinking. It has a huge amount of packages available. These, for instance, for science, like SciPy, NumPy, and Pandas. You can even do GUI development, say for Windows and Linux. And in fact, remember, if you write it for Windows with PyQt, it should work on Linux too. So you get both platforms. It has APIs to other systems like LinkedIn, Craigslist, Beautiful Soup, which you can use to scrape web pages with and garner information from websites. You can do machine learning with TensorFlow. There's even some natural language processing and analysis packages like NLTK and facial recognition. So you really have it all. If you can think of something that's built in another language, it's probably available as a package in Python. And in fact, just a word, if you find a package written in, say, Fortran or C, you can actually access that from Python as well. There are mechanisms for binding the native language libraries directly into the Python. We won't talk about it, but they're there. We can talk about it. Yes?
I just wanted to know, is Python still considered the #1 language to develop AI?
I think so, because it's pretty agile and quick. The packages like TensorFlow, they have backends that are written in something much faster, but the APIs are there so that it makes it easy for you to set up a training and later execute the model. So I still think a lot of people use Python for AI.
It seems like Java could be used for AI too.
It could. But I think the guts of, for instance, like TensorFlow is probably written in something native like C or C++ or something like that. But let's go ahead and get started. We'll talk about it later, but there are objects in Python, and they have properties and methods just like any other object-oriented language. So how do you want to get your Python? Well, you can get your Python from any number of these sites. Anaconda is really convenient. But you can actually go to python.org and get it if you want. And once you get it, you want to have access to all the packages. That's done by going to PyPy, which is PYPI, and you use something called pip to install packages. The wording is typically pip space install and then the package you want. In fact, the instructions to do it are right on PyPy. And if you don't want to make any commitments, you're one of those kind of people, you can use PyFiddle and just play in a browser. So a few miscellaneous things about Python. It's interpretive, case sensitive. It uses the pound sign for comments. Star is a wild card, just like it is in many of the other languages. And a single equal sign is an assignment, and two double equal signs are, equivalence tests, just like C if you've used that. It has a few data types, for instance, numbers. You can have floats and integers, strings. There's a structure that comes with the language called lists, which is an ordered type of objects. And what's really cool about lists is you can put anything in the list. It's not a homogeneous list, it's a heterogeneous list. Same thing with dictionaries. You can have a key value store that has heterogeneous data in it. It will be your job to figure out what it is before you call it, but it's there. And you have something called tuples. Tuples are like a list, they're ordered, but they're immutable. And one of the biggest uses of a tuple is it acts as a key for dictionaries. So your key in the dictionary can actually be, well, it's not a list, it's a tuple, but it could be a list of things as long as it's in a tuple. So they can be multi-value. There's also something called set, but we didn't really talk about it. It's a list where the items in it are unique. So let's talk about numbers. Numbers, you assign the values with an equal sign. You can cast numbers using int and float. There's a function called stir that lets you turn numbers into strings. And with that, remember, you can't concatenate numbers and strings, but you can if you turn it into a string and then concatenate it. So here are some examples. And please, if you want to see me do something, because this is all very interactive. Here we're just assigning a number and we're printing it. So print will figure out what type it is and print it. Here we're saying print, hey, it's a float. I didn't have to put a format statement. There's an int. And here's me turning a number into a string. Now, interesting, when you, on the prompt, if you just hit, type in a variable and hit a return, it will automatically print the value of it. And so that's why you see the 14 there as quotes. We didn't say print it, but because it was just standalone, it did it anyway. So some of the other things you can do here with these types, I could take a year and I could format it into a string. And this is sort of interesting. This is an old style format statement. Doesn't need to be part of the print. You can use it for other things. But what we're saying here is, I want you to take the first element of the format list and put it in this 0. You can do a 1, a 2, a 3. And so each positional element inside of the format call ends up being substituted into the string, and then we can print it. Let's just do it. We can also just say, use the F formatting, which is very nice. Let's just put the variable right there. So now it's easy to read, right? I can see I'm going to print the year for number. And it could be standalone as well. See, like here. And it has a lot of other uses. So if I just want to put together a file name, I can use that magic F formatting string outside of the context of print and just make it part of my data. So that's that. And this one, oh, can anybody tell me why that happened? Well, the output of an open statement is a file pointer. And a file pointer is an object. So it can't really print the whole thing, but it tells you, hey, I have this thing called an IO text wrapper that I've got the reference to. If I'd have put this here, then it wouldn't have come out because it wasn't standalone by itself. Hi. Hello. We just kind of got started. Any experience with languages? Anything?
Yeah, C.
Oh yeah, you're gonna be fine. You can just roll with it. The one thing you will want is that if you want to get back at the material, because I have it in GitHub. Okay. And I'm probably not going fast enough for some, and I'm probably going too fast for others. So tell me to slow down or speed up or whatever you want me to do. Yes.
Is Python free to download?
Yep. Yes, it is. Anaconda has programs where you can, as a company, you can subscribe to the enterprise, and that gives you, it doesn't give you much, but it sort of indemnifies whoever uses their product. And a lot of companies do that. They'll pay for open source software just so they get indemnified from copyright infringement. I know that's why we do it, for instance. So let's talk about the operators. They're similar to C++, right? You've seen these before. Addition, subtraction, multiplication, division, modulus, exponents, floor or division. Here's some operators for comparison. All the standard culprits you see in C. Sir, what was your language background?
Fortran?
Yeah, okay, so these are all familiar to you too. So strings can be defined by either single or double quotes. Make sure you use the same kind of quote on each end. So if you use a single quote, you got to end it in a single quote. It's basically a collection of characters, which is considered a list of car. So you can index into it via an indexer. And in fact, there's slices that you could take with I think we'll get to. Remember, your backslashes are escape characters, but you can use a magic or a magic indicator R, which says that the string is raw, which means don't interpret any of the slashes as part of a control sequence. And it's useful if it contains backslashes. And you can concatenate the strings together with plus. So here's an example of a string. Hello world. I put it together. I can overassign it. I can reassign it. I could look at each of the elements separately by indexing. In this particular case, notice here I had to put double slashes for the single slash. And then on the second one, I said, I don't want to do that. Let's just use the R. So it's very useful. Boom. And there's also an F, which we talked about, which does formatting really nicely. You'll want to look at that. But there's maybe about 5 different characters that mean things. I think one is B for binary and things like that. So you might want to research those. And here's a concatenation. Boom. Now there's a wealth of functions that you can use on string. For instance, you can ask it, does it start with something? Does it end with something? Of course, is it alphanumeric? You can replace some substring with some other string. Doesn't have to be character, it could be more than one character, because there really isn't any difference. And over here, by the way, are examples. You could split a string on a separator. So one of the things it's really nice to do is you get this big long string of things separated with space. You want to tokenize it, turn it into a bunch of tokens. You could just call split with the space that's a character, and it will create an array of all the different elements of that single string. And then strip is synonymous with trim, if you've ever seen that. It takes the white space off the back and the front. Yep. Oh yeah, there's a lot of regular expression stuff available too. We probably don't get into that here, but there's a package, I think, that does regex. If we look at lists are declared with double brackets like that, and enclosed with brackets like that. They're ordered, so it'll be the first, second, third, fourth, and they're indexed from 0. Okay. Items on the list can be different types, so they don't all have to be strings. They don't have to all be ints. They can be objects. They can be different kind of objects. And you can even have different kind of objects and call them all the same way with something called duck typing, which I'll talk about in my next talk when I do object-oriented discussions about Python. So you give it an indexer. We talked about that. Oh, and we'll talk about list comprehensions, which is a shorthand way of creating a list with some Boolean logic. So right now, we're just gonna make a list. We're gonna put some cities in it. We're gonna print all the cities, and then we're gonna print each city independently. Voila. We can make a list of numbers, we can print the list, and we can use this thing called a list comprehension right here. And what we're gonna do is we're gonna make this list equal to this list, but for each item in the list, we're going to only take the values that are even. Mod 2, right? So if mod 2 is equal to 0, that means it's divisible by 2. So only the numbers divisible by 2 should end up in my list, and I'll have quickly made a new list of just the even elements. Any questions on that? Okay, and in fact, it could get really complicated, right? You can have a list comprehension inside of a list comprehension. So lists have some significant methods that you could call on them. So you can sort, you can append an item. Oh, didn't mean to do that. That's the formatting underneath. You could append an item, you can sort it, you could reverse the items in the list. You can remove an item by its value, like over here. You can insert an item at a specific location. In this case, put the Z at the front of the list, and you can ask how many items are in the list, or you can count how many of a particular item are in the list. So how many C's are there? There's only one C in the list. And something we didn't do is if I go list -1, what do you think is going to happen? Remember, the list will be the 0, 2, 4, 6, and 8. What value will come back? Well, what it does is it indexes when the index is negative, it indexes from the back. So this will give us the last item. Unless I lie. No, I didn't. See how that is? See that? So if I say -2, I would get the second to the last item. And then of course, what is that going to do? And let's make it more interesting. What's that going to do? That's going to start at 2, position 2. It's going to give me the 4, and it's going to give me the 6. It's going to make a slice of the list. I think that's right. No, I lied.
So it's getting the second item as the third item. Second to last.
Right. It takes, let's do this. There. So it goes 2 in on this end, and it goes 2 in on this end, and it gives me everything in between. And I made a new list that's a slice of the old list. So there's really interesting things you can do with indexing in Python. The what?
Yes.
Yeah, that's colon. Yes. Is it? Do I need to make it bigger? Or is it generally okay?
A little bigger over there. That's one side thing. A little bigger over there.
Okay. Okay. So those are all the methods. Now we have dictionaries. As I said, dictionaries are an unordered set. There's no order. You can actually iterate over a dictionary, but it's not going to guarantee the order. Did it just change back? Interesting. Okay. They could be different types, just like they can be in a list. You can index by the key, so you can enclose it in quotes like you can right there. And we can make dictionary comprehensions, which is a quick way of making a dictionary from a dictionary or a dictionary from a list or whatever. So here we are. We're going to declare a dictionary using the 2 curly braces. We're going to put we're going to put a 1 in cat, and we're going to put a string called happy in dog. And then we're going to print our empty dictionary, but we're going to format it so that we get the string cat equals whatever, and then dog equals whatever. And you can see it doesn't care. It didn't care what the types were. Likewise, we can tell it that we want to make a dictionary using the I guess like a static initializing way. We can say that the key Houston is this number, Austin is that number, Dallas is this number, and then we can say print all those values, and then we can say print Austin. So it prints the entire dictionary for us so we can see it, and then it prints the value for Austin when we use Austin as an index. So if we want to make a comprehension, a dictionary comprehension, we're going to call it city populations. We're going to use that variable again. Okay. So we're going to take the city populations items, which just gives me a list of all the items. And those items come in as key value pairs. So there's the key, there's the value. So for each key and value, what I want you to do is give me a key value in my dictionary where the numbers, again, are even. So we should get Houston and we should get Dallas. Unless I'm wrong. I'm not. Okay. And of course, I told you the city populations items returns a list of the dictionary items that you can then use. And we talked about this method items. We talked about keys. We talked about values. We could do that. So if I put values up here, it just gives us the values instead of the keys. We can return an item from the dictionary and delete it. And we can clear a dictionary. Excuse me. Any questions? No? Or just kind of like ramming through the syntax, but I want to make sure everybody kind of understands what's going on. Okay. So the third data structure that Python provides is tuples. As I said, tuples are an ordered set, much like list, except they're immutable. You can't change them. And partially one of the reasons they have to be immutable is that we use them as indexes into dictionaries. And you can't make a dictionary with keys that are mutable because it would drive the dictionary structure nuts. So that's one of the reasons why it's useful that they're immutable, I mean. They have a very similar features and capabilities that lists have. So we'll probably see many of the same methods. So you declare a tuple using parentheses, and you just list the items in it. And again, tuples can be heterogeneous, right? You can have any type of item in your tuple. So you can pair up a person record and an address record, and all the different things, bundle it all up into a tuple and pass it on down the line to be processed somewhere else. And in fact, it's a way of returning a value in Python as a single value if you want to pass a function value back as a single value. But it turns out Python can actually return multiple values in a function call, which is, and since I mentioned it, I now got to show you, it's like this. So this is what you call a Python function. Okay. And Python, as I said, you have to use indentation to show the levels. We had a lot of them, yeah, which we'll talk about in a minute. And then I could say return A, comma B, and Then down here, I can say foo. Well, that won't work because we don't have an A and a B. Let's just say 1 and 2. This should work. Yeah, it worked. So it returns values for you. You can return multiple values. You looked like you really liked that feature, so I decided to show it. Back on our tuples, but that's not a tuple, that's a dictionary. Okay, okay, okay. See, here we're making a dictionary, and we're going to index it using these tuples. There's a tuple, there's another tuple, etc. And now we have a dictionary that is actually indexed by a data structure. And so Python, does all the hash calculates the hash and whatnot for it, and everything's great. And then we can put in, what is this doing? Why is that a problem? That's a problem because we made a tuple called person with the first name and a last name, and then we tried to reset the first name. But a tuple is immutable, so it won't let us do it. That's what I'm trying to illustrate there. So let's talk about the looping structures. Okay, so all the conditionals and all the loop statements end with the colon. Try to do this again there. And the code within it has to be nested. So you're going to see nesting, and nesting is important. The first statement, the first statement type is an if, else if, else, or else if. You can have if else. Doesn't have to have the else if, but you've probably seen this in many of the other languages you play with. We're going to set pi. We're going to say, is pi greater than 4, which it should be. Was it greater than 3? No. So it should tell us that pi is not greater than 3. So you kind of understand that. Does that illustrate how that all works? Okay. Here I've doubly nested an if. So I have this if with an else here, and then an if inside. And the only way you can tell what's going on here is by the indentation. And be aware that if you use a tab on one of these and a space and spaces on the other, you may get a message that says inconsistent use of spaces or tabs to blah, blah, blah. So be consistent, but it will take either spaces or tabs. It's kind of weird. So we can go on to the for statement. We use these to iterate over things like lists, tuples, dictionaries. You have break and continue, just like you have in other languages. But unlike other languages, it has an else clause. Now, I think I've got this figured out because we had this discussion the last time. The else is only executed if the list exits normally. So if I've got a list, if I've got a loop that's looking for something, and when I find it, I break, the else won't get fired. But if loop and I'm looking for something and I don't find it, and the loop terminates because I've reached the end, then the else will fire. So it's a way of saying I couldn't find it. So it's only executed if the loop exits normally without a break. So here's just a simple for loop. We're going to take this list. We're going to loop over it. We say for X in the list, print X, and boom, it just prints all the values. And here, it's interesting. So in Fortran, you could say for I equal 1 to some number, or in C++, you could say for equal to 1, as long as the I is less than 10, I++, things like that. We don't do lists that way. You have to iterate over a range or a list. Now, in this case, there's a function called range that will generate the numbers 0 through 9 because it never generates the last number. It doesn't include this in the generation. So this will do 10 entries. In the old days, this would actually generate a list and it would look just like that. But nowadays there's a thing called an iterator type variable. So what will happen is every time you call this function range, you just get the next number. So it doesn't physically create a list, because it could be a lot of trouble, right? If I want to have, from 0 to 1,000,000, I don't want to make a list that's 1,000,000 long. So it's been changed, so it's very efficient that way. This should generate the same thing we have up above, and it does. 10's not included. Now in this particular case,
So in that case, it says it's L, numbers you want from the starting.
right, but you could start from some other number.
Right, well, I'm saying though, is you did 0,11, then it should actually show you 0.
Yes. And remember, you have this over here. Oh, I put it on the outside, dang it. Right, so you have step size. And in pandas, if you use pandas or something like that, I think there's a way of doing this with floating point numbers as well. In this one, we're going to use an else. Because the list is going to terminate normally because there's no break, it should not go through the else. So it says, it should go through the else because it terminated normally, right? But if I go up here and say, let's print 1 and then let's break the list. Now, they lied. I have to figure that one out. Every year we have that problem. I can't figure out how that works. Okay, so let's just go on to the next one. Loops are used to iterate over until some criteria is met. Most of you are probably familiar with loops, with while. While is very much like anything else. So we'll do this while count is less than 9, and boom, it goes 0 through 8. I don't even want to talk about it because it doesn't seem to do what I think it's going to do. Because I was told, oh boy. Well, actually, it did work there. Right? When I didn't get out of the loop. I'll have to go back and look at the other one later. Okay, so in this one, what are we doing? Yeah, we're gonna talk about that. So down here, you see the word path. When you're writing code, you'll say, I want to put a loop here. So you put the loop header and then nothing. It doesn't like places where it expects some indented data to be. If there's nothing there, it'll complain. Like, let's say I haven't written this part yet, right? So it's like this. If I run that, it's going to say, well, I don't expect an indented block. So pass is a form of no while. That I can put something there, I can get the structure of the program correct so that it will execute if I want to run it to test it. So it's just a way of saying no op. There's something will come here later on. Useful only when you're writing stuff. So now we're going to talk about modules. Modules are those things you see at the top of your list called import, and they import, functional libraries that you're going to use basically. So something somebody else wrote, okay? And in this case, what I call other people's code, OPPC. So here, for instance, is operating system functions. Sys is about system-specific parameters. Glob is the Unix style path name pattern. CSV is for reading and writing CSVs. So if I import sys, I can get at the version and it will tell me what version of Python I have. And there, it tells me what version I have. Not only that, it told me how it got compiled. Got compiled by GCC. In this particular case, I want to get the current working directory. That's my current working directory. You can actually ask it what operating system you're using and what kind of machine you're on. So you can write code that detects whether you're on Windows or Linux or anything like that. In this case, we said import, and everything we imported in sys has to be prefixed to the word sys. Here, we said, I don't want to write, OS is too many characters. So I'm going to reassign that inside my code so it's O. So now I can just use O, but it means OS, if that makes sense. Now what we're going to do is we're going to go to the time package, and I only want to use the function sleep in that package. So I will import only sleep, and I will sleep, and then when I'm done, I'll print a message. So I can import everything. I can change imports so that I get an alias. I can import only specific methods, or, and again, in that case, right, yeah, I can import sleep, but just import sleep. I can import everything with the star that says, take everything and ran the package random, shove it into my namespace, and none of it has to be prefixed. So I don't have to list all the individual elements. It just all comes in. Kind of okay, but you can imagine how you might get a polluted namespace if you did it too much. And there you go. So I can now use rand in, without ever having to know it's there. And all the other random functions are available too, without any prefix. And that is what I had. I think I've got 20 minutes. Did I get 20 minutes? No. Come on, questions. Dialogue.
You see teacher members when you wanted to check the list. Can you put variables instead? Because you said from 0 to 10 or from.
Oh, yeah. You can go, for instance, here, I can say, now the problem is, it got mad because, so you mean this right here? It's the thumb pad. My thumb hits it. Okay, now we run that, same thing. No big deal. Well, I don't think it would, well, first of all, these are integers. So you mean,
So that inside of this. And that, I find.
ooh. We have to actually have something that's a variable. So I'm going to put, we actually can't do this now. You want this. Okay, so we have an exit list. We're going to set to 2, and then we're going to print list right there. I don't think it changes it because it's
Because that's all.
it's a number itself. Now, if you wanted to make it an object, you could set the object values in it, I bet. So for instance, if this is we're gonna only have one. Well, maybe we'll only have one. So I think you can do this. Don't need to say int. Just say value equal 0. Boy, now my C++ is coming out. I want to put semicolons after things. And then we're going to go. I think that's right. Okay, there was okay, those are two objects now, right? And then what we're going to do is do this twice. First time we'll change it. The second time we'll print the value. And here we don't actually, we're just going to change it. So we're going to say x equals x value equals 2. Yeah, that works, right? Because now it's not the number, just the number sitting there is something you can't intrinsically change. But if you if you have a container, you can change the values in it.
Look up one, probably at that rail, where you had the open file. One.
Oh. Yep, it's someplace. I know what you're talking about. Right here. Yes.
Okay, so that's actually just that data out of that file name.
Well, basically, this is the statement that opens a file.
Okay.
This was its name, and the name is constructed using an F string and initializing it with two different values, directory name and file name, which are up here. So if I actually can't print it. I can do this. This became that, right? Or am I missing it?
No. The only thing in that file is that very last statement, number equals 2018.
Actually, there's nothing in that. We didn't redo anything of that file except open it.
Oh, okay.
Yeah. All I was just trying to show here is that this F formatting thing has a lot more utility than just around printing out values. Anywhere where you make strings and you want to put them together, you can do it with an F string if you want.
You could have a separate file with a list in it and import that list into your studies.
Yes, you could. It would probably be something like F dot read lines, read lines. I think that's right. And then I would have to go to. Of course, we need that. Yeah, we need that too. What? Okay, can I do it here? New window, there we go. Okay. Oh, project. And is that where I put it? Where did I put it? Where did I put, oh, put it in S communities, which is basically back up here. Okay. Ah, I got stuff in it. Cool. I wasn't sure I had anything in the file. So if you do this, I think it will spill out. Yeah. Read lines reads all the lines of the file. And since I didn't put the lines in anything, they just spill out on the terminal. But if I wanted to read this file, there, all the lines are now in a variable lines. Now, the problem is we didn't close that file, which is bad. Okay, so there's a way around that. you say with open I think as F. And what's really cool is, and this is part of their object orientedness, you can extend the language using this with thing. And in this case, I say with open file thingy, blah, blah, blah. The file will be there. I can read it. And then when it goes out of scope, it closes it automatically. And so now it's in lines. I guess we ought to do lines so you can see for sure, but you never know. I might be selling snake oil. I don't know. I am selling snake oil. Python snake. Yes.
Yeah, sort of two big questions. First, I mean, I've been programming for quite some time, like MATLAB, R.
Yeah.
And C. But, you know, haven't only Python is only for training courses. The first thing is how do I remember the syntax? You know, for the big. And second, if sometimes I need to brush up Python quickly, is that the easiest thing is will Coursera have a reports and something, or you have some other suggestions?
So I have the problem that I have to switch between a lot of different languages at work. Fortran, C++, sometimes Python, sometimes HTML, TypeScript, you know, all kinds of weird stuff. Because I'm like a fixer. And so, yeah, I'll forget. And I Google it. You know, I'll say, oh, how do I do a dictionary comprehension? So I'll just type Python dictionary comprehension, boom, comes up. Oh yeah, now I know. And if I'm using it today and I use it tomorrow, I'm okay, right? Because it's kind of still fresh in my mind. But for instance, like C++, I haven't used C++ in actually probably a year or so. So yeah, I kind of forget some of that. The other thing is you can just, and I showed everybody else this. This is almost like a list of, these are the syntax operations Python, and it's all hosted on GitHub. You can go get this, or you can look at it whenever you want. And it's there as either a Python notebook. It's also there as a PDF with all the cells run, so you can see what the values would have been. And you can just find yourself a cheat sheet. Cheat sheets are great. Yep.
Does Python do inheritance?
But you don't need it. So I can make a class that has a method in it called run, and I can call it car. And I can make another class called boat that has run in it. They don't have to have any common base class at all. I could put them in a list and I can iterate over the objects and call run on them. And it doesn't have a problem with that. So they have what's called duck typing, which means if it walks like a duck and it quacks like a duck, it must be a duck. So if it's got the method, I'll call it. Videos, you've got a video that's got a play method, and you got a sound file that's got a play method. It doesn't matter. I'll play whatever you give me. And what's really weird is I believe you can get an object and you can add a method to it. So you could say, oh, I'm going to go to the system printer. I get a package, that's got like a list of printer management package. And you can get a printer out of the printer management package, which is some object that it has. You can add another method to it. And then you can put it back in the list. And later on, you can come back and go, oh, I got a printer. Does this printer have this method? If it does, we'll call it. If it doesn't, we won't.
So related to the previous question is, so if you, for example, if you have interview questions on Python right on the whiteboard or type thing, you just a few days.
Right.
Intensive Python can help you.
Okay, I think in that case, I would recommend look at LEET code, LEET code, which is a huge database of a bunch of Python examples which employers use. That might help.
Something.
Yeah.
How do you declare arrays? No, real numbers.
Real numbers? Okay. Do you want me to declare it with something in it?
No, that's just the empty three-dimensional array.
Oh, you want dimensions? No. Well, that would be a list in lists inside of lists. So there's no two-dimensionality built into the language. Now that I say that, but really what you want is you want pandas.
Well, I
Pan-
want, let's say, three-dimensional arrays, which would have, like, let's look at this row, it's three-dimensional. I would have to coordinates of every point inside the row.
Right,
to
right.
find it.
And you want to put together a triple nested loop that goes for 1 to n, for
Yeah.
1 to m, and 1
Exactly.
to t, and goes through all the elements. You can do that, but you're not going to be able to do that with the base language objects that are defined. There's a package called pandas, or NumPy might even do it too. What they do is they provide, I think they provide dimensional arrays. And what's also good about them is they're super fast. And the reason they're super fast is all of the things that get done, like when you want to multiply, say you want to multiply 2 arrays together, right? Oh, that's implemented in native code. There's no Python bytecode or anything like that going on. Because remember, this is interpreted. When you run a Python file, a .py file, it creates a file called PYC, which is kind of like the precompiled bytecode of the Python, and it stashes it in a directory called under Python under, and it puts it down there. And when it starts up, it goes, "Oh, there's one there, and it's the right date. It's not out of date. Let's use that." And so that goes on. So if you really want to do numerical, you want to use pandas or NumPy, because you'll get way better performance anyway. Anybody else? Yep.
You said that Python is an interpreted language.
Yep.
But can you compile it also?
There's something called Python, which lets you write Python code. It's C Python. Is it? Oh, I gotta look that one up because I can't tell you for sure. But yeah, it's called Python like that. And what it,
A Python.
yeah, Python, Cython. And what it lets you do is it lets you write Python and it gets compiled down. But it's like packages, pieces, right? You can also, let's say you got some really sophisticated numerical stuff. You can write that in C++, Fortran, C, anything that has a C binding, and then you can connect to it using Swig, which would be one, SWIG. If you're on Windows, you can use Win32, which is a Python package that allows you to make C bindings from your Python. And then your arguments, it just looks like a Python call. So you can say, "Oh, I need to do this thing. Okay, now drop down and do a Jacobian for me." Okay, done. So you could make 98% of your code Python, where you're doing all your workflow and iterative kind of stuff, but then the numerical can all drop down into native and be done in native. Wouldn't recommend doing it in assembly because I don't think anybody can write assembly as fast as C++ can run code now. They've got optimizations really, really, really good. I gotta be here till 3:20, so I got plenty of time. Well, let's see, 3:20. So 1:30, we start the next one. Okay, take a break, guys.